Greetings, everyone. Thank you for taking the time to join us at today's webinar. We will begin our session in 10 minutes, so sit back, relax, and we will speak with you again shortly. Hello again, everyone. Welcome to today's webinar. My name is Dina Menon from Electronics and Engineering Private Limited, and I am joined today by Jamie Kwa, Vic Teo, and Gerald Marcus from Shure South Asia Limited. Gerald Marcus is joining us remotely for the session. Today, we also have with us our guest speaker, Robert Su from Cogent Acoustics, who is here to share with us more about audio engineering in houses of worships. Before we get into the session proper, allow me to share some housekeeping guidelines. This webinar will be recorded and will be available for playback once it is ready. The lucky winner of a Shure MV7 will be announced in our thank you email, where a link to the recorded session will also be shared. During the webinar, if you have any questions, please feel free to type those into the question pane. If you don't see the question pane, there are one or two places you can find it, depending on how you are logged in today. If you are using the web app GoToWebinar, you should see a question mark and a circle, so just click on that. If you are using the actual application GoToWebinar, look for the dark gray toolbar with the orange box with a white arrow in it. Click on that orange box and you should be able to access the question pane there. You may type the questions as the webinar progresses, but please note that we will be holding off question and answers until the end of today's session. Lastly, as we are not all broadcasting from our usual control environments, but instead live from our homes and limited office space, we seek your understanding should we encounter any audio or technical issues. This wraps up housekeeping. Please allow me to welcome again and introduce to you our presenter for today, Robert Su, consultant, Cogent Acoustics. Robert has been in the industry since the 80s. A proficient worship leader, he has served both as technical director and worship pastor. He then moved on to developing professional microphones, audio devices, and communication systems for an American MNC. In 2011, Robert started Cogent Acoustics, a consultancy firm that provides AV and acoustic system design and training services. Robert has many years of audio professional experience in the industry and has accumulated a wealth of experience serving as solutions counsel for many. Without further ado, please allow me to also introduce again Jamie Kwa and Vic Teo from Shure South Asia Limited, who will be on today's panel together with Robert Su. Jamie, over to you.
Thank you, Dina, for the good introduction, and welcome one and all for joining us today, taking your evenings to actually join us to share and also to learn from Robert. So without further ado, let me just hand it over to Robert to kickstart this session right away.
Okay, great. Well, thanks once again. Thank you, E&E and Shure, for organizing this session and the opportunity to share about this topic. So I'm not sure if there's something else that you need to add on. If not, I'll just move on to my section proper.
Before a serious topic, perhaps we talk about who's going to win for the Euro.
It's anybody's guess. Yeah.
Okay.
I'm nobody's supporter. I just watch soccer just to enjoy the game. But yeah.
Okay, cool.
Anybody's game.
So Italia, Forza Italia.
All right. Okay.
Not sure about the rest.
Okay, good. Okay.
Yeah.
So let me just move on to today's topic. Okay, and we call it audio engineering for houses of worship. It sounds like a really big title, but don't worry, I'm not going to go into formulas for intermodulation or how do you set up your IR filters or even talk about schematics for wireless. Right? I'm not going to talk any of that for a couple of reasons. One is probably you send some of you to sleep straight away, and secondly, I don't even know whether I'm good enough to talk about this topic. So, but what I want to focus on, right, more importantly, is on some important handles, right, that I feel that every wireless user must know, right? Because in my work, in my encounter with various clients, various projects, users of wireless systems, I gathered a lot of things over the years and discovered that even though wireless systems have been around for a long time, I still feel that a lot of people still do not know much about it. So I think today's topic is really useful. So let me just go into the topics, right, for today. I'm going to touch about IMDA regulations. Now, some people are wondering, what on earth is this? But don't worry, we're going to that, right? And we're going to go into wireless system fundamentals and system options. We're going to talk about common causes of RF dropouts and interferences. And we're going to talk about proper receiver antenna placement positioning, followed by antenna distribution and combiner systems. And finally, rounding off, I'm going to talk about batteries for wireless systems, which is kind of strange for a wireless, webinar.
It's good to know.
Yeah, but
It's added
yeah, I just want to do it, all right, because I felt it's very important.
Right.
Okay, let me just quickly go into IMDA regulations. Now, I'm not sure how many of you actually have heard of IMDA, but they made a very important announcement some time back. So let me just go into some of the details here. Now, IMDA basically stands for the Infocom Media Development Authority. They are a governing body in Singapore that supports, develops, and regulates the Infocom media sector, right? And they made a very important announcement, actually, all the way back in 2017, about a certain frequency band that's being released for the provision of certain commercial services, right? And now, why is this important to us? It's because it actually affects, right, our wireless microphone systems as well as our wireless in-ear monitoring systems, some of which are, very heavily used in houses of worship today, right? And all these are basically categorized under what they call short-range devices, right? Or in short, they call it SRD, right? So if you see this term SRD, you know what it means, okay? So a little bit more details about that. So here's a little bit more description about what they talked about, right? Back in 2018 April, right? They made this announcement. This is actually found on IMDA's website. This is where I got it from, right? To cut a long story short, right, with effect from 14 September. So that was the effective date, right? 2018. The main announcement that any equipment registration will only be accepted for equipment operating in the frequency band 470 to 698. Now, what does that mean, right? So it basically just says that from that point onwards, right, technically you should only be using wireless equipment that operates within these frequencies, right, and nothing else, right? So if you would like to find out more, you can go into the IMDA website, right? You'll find this document, right? They call it the Spectrum Management Handbook, right? In there, I extracted a small section which pertains to more of our wireless systems, right? So if you look at it, let me just put it out, right? You'll see these are the affected devices and respective frequency bands and RF output power. Now, how do you interpret this table, right? Now, if you look at it again, you'll see that you see that SRD being mentioned here, right? And for short-range devices, we are basically referring to the wireless microphone and wireless IEM systems. Okay. Now, what's important to note on this table, you see this thing here. All right. It mentions it must operate within 470 to 698 megahertz. All right, and the transmitting power, all right, is 10 milliwatts. Now, some of you may not have come across this term before. Okay. The ERP basically is the emitting power. All right. In wireless systems, you can have an emitting power of 10 milliwatts, sometimes 30 milliwatts, sometimes 50 milliwatts, something that's very common in the past. But take note that in Singapore and some neighboring countries, probably Malaysia and Indonesia and somewhere, right? I think they all have a similar requirement that they can only have a maximum of 10 milliwatt power, right? Anything, right? The power refers to how much it can transmit over a certain distance, right? Right. The higher the power, the further the range. Basically, that's what it is. So in Singapore and perhaps in the neighboring countries, they have this requirement, 10 milliwatts, nothing more. Okay. And then if you look at the table below, right, you'll see even the hearing audio assistant aids. Okay? Some of the houses of worship are using this regularly for maybe translation purposes, language translation, or they use it for conferences and so forth. They even have a regulation for that. Okay, so do take note about this. Right. Later, I'll explain to you why it is so important to know this. All right. Now, that's a very nice chart that I want to show you. Very colorful, right? I know maybe on your screen you can't see much of it, but probably you can see what's on the left side, right, of the screen. You'll see the frequencies spectrum. All right, and what really affects our devices are this little section here. Where is it? All right, it's circled here. Right, that shows the 470. It actually shows up to 790, I think, something like that. But what we are concerned about is basically 470 to 698. You can see down there is kind of written as broadcast. All right, but for the rest of the spectrum, right, it's not meant for us to use. They are used for commercial. They're using for
Digital TVs.
Yeah, digital TVs or the military use or scientific use or whatever it is.
Yep.
Right, and there's a little section as well here. That's where our 2.4 gigahertz range is. So that little section out of the massive spectrum, right? So those are the only sections that are allowed for us to use at this point in time. So do take note of that, right? Maybe in the past there was a little bit more, but now it's getting smaller and smaller. It's shrinking, all right? And that affects us a lot. Now, if I were to make some reference to, let's say, the Shure devices, right? Maybe in the past they were offered in the range of 470 to 790 megahertz. You can see some of the models being represented there. And of course, we also have the 2.4 gigahertz models, right? Now, if you own any of them from this 700 megahertz onwards, right? I'm sorry, you can't use them anymore, right? So technically, right, this has been reduced to 470, 698.
Yep.
That's what it is. And of course, if you have any equipment that's still operating in 2.4 gigahertz, you're safe. That's fine. Nothing changes there. So don't worry about that. Now, so if I were to ask, how are houses of worship affected by this regulation? Okay, so I've been talking a lot about IMDA and what they have announced over the years. Okay, what it means is that, right? Okay, let me just go back to this, right? Now, I realize that many houses of worship today are still unaware of this. That's why I'm making this emphasis. Right? I visited a lot of houses of worship, and a lot of them are still using wireless systems that are still operating in the so-called affected range, which is above 698. Right? And a question that I'll ask them is, how come you're still using this? And they will give me a very puzzled response and says, what's wrong with using this? I've been using this for years.
Yep.
Right? And when I told them that, don't you know about this regulation? And a lot of them said, no, they don't know about it. In fact, it's been in effect for a couple of years or 3 years or so. Right? And I said, okay, this is bad. Probably the news never reached you for some reason. All right. So in cases like this, you're highly advised that to have this system replaced as soon as possible, because what happens is that anything above 700 has been made available for other users, right? And those other users are already in effect, which means that there runs a risk that your equipment may be interfering with theirs, or theirs interfering with yours.
Yep.
Okay, whichever case it is not good. All right, so we have to do something about it. And you also need to do that just to avoid, getting in some issues with the authorities who are governing the RF space. So some of you may not have encountered this, but I have many years ago when I was still operating in one of the auditoriums. One day I got a knock on the door, and I got a telco looking for me. And it says, I think there's something in your building that's interfering with our systems. I says, oh no. All right, so to cut a long story short, they found nothing. They thought that it was existing in my auditorium, but it wasn't. But still, they are doing their rounds, right? If they have some issues with their equipment, they will go and search and says who is using this, who is interfering with this, right? So I hope you don't get in that situation, and that's the reason why we want to talk about this in this webinar.
I think on the chip regarding about that, Robert, it's a good case study, because I have faced one situation as well, that for the 2 years back, right, there's one higher education institutions. They did try, all these frequency band which is exceeded 700 megahertz.
Yeah.
But eventually it's not that bad yet.
Yeah.
But recently this year itself, when I visited them, they are using, apparently they have a new systems, they trade in, they have a new systems, but they have a very bad situation with the current new systems. So when their old system, which is exceeded 700 megahertz, right, is they thought that they are to bring back the old equipment, try it, then totally none. It cannot be used.
Yeah.
Yeah, it's so bad about that. So
yeah.
So just one of the case study I'll share about that.
Yeah, thanks. That's a great story.
Right.
In fact, a lot of houses of worship people, users, are very puzzled because when I told them, do you know that this space has already been given up? You're not supposed to use it. And they said, no, I've been using it every week and nothing is wrong. All right. So in cases like that, all I can say is, you know, in the Christian world, we have this phrase that says, you have been living by grace. All right. So basically, you know, you are very fortunate and you didn't get into any problems, all right, in that frequency. But in your case, as you mentioned, right, it will only catch up with you. All right.
Yes.
Sooner or later, it's going to come in and someone's going to interfere with your system or yours with theirs. All right. So don't take that chance, right? Anyway, the regulation already has been there. So go ahead and make that move.
Yep.
Right,
Agree with that. Agree with that.
Yeah. Okay. Let's move on.
Yep.
So what needs to be done then, right? And what solutions are available to mitigate this? Okay. So firstly, go and identify what existing systems that you have that are currently operating in the affected band, meaning anything that is above 698, right? 700 all the way to 900 megahertz. Usually that's where the wireless systems are operating in, right, in the past. Okay. So, and some of you may be wondering, though, how do I check that? Okay, a lot of these wireless equipment, whether it is the wireless body pack, right, or the receivers, right, they will have this little label. Okay, so I got this example here, right? If you see the body pack on the left, right, I think that part is circled, like can you just blow it up so you can see a little bit more details. You can see that it is written as 780 to 822 megahertz. So this is definitely a no-no, right? So if you have such things, right, you're not supposed to be using it anymore.
But I have a question. So if let's say there's clients, right, they have analog systems, analog wireless mic systems, so it's comply with IMDA. So how do you would like to advise the clients to upgrade into this wireless? If let's say some clients say, hey, I've checked all the equipment, it's complied, yeah, I just comply with the government.
Yeah.
So how do you advise to the clients for all these house of worships?
All right, which means that they already have analog systems and
within the range of IMDA compliant, 470 to 698.
they change.
Yeah, sure.
Well,
even though it's analog.
yeah, technically, okay, this is where I'm coming across. You know, in my position as consultant, all right, I'm not here to make people buy things, right, for no reason. So if I can help you save money and say, nope, you don't need to change, everything's fine, that'll be great, right? But you may have other reasons for changing or upgrading, right?
Right.
So if let's say your systems are very new, maybe a couple of years, 3 years, let's consider quite new, right? And they're working fine for you, and there are no problems, sound great, you know, you like it. Actually, there's absolutely no reason.
True.
Right.
True.
I'm sorry. Hopefully I'm not trying to affect your sales here.
Fully understand that. No,
right.
No worries about that.
Yeah. So there's no reason. But if you have other reasons, like for example, you may encounter situations where, okay, I'm going to go more into detail about that. All right. The nice thing about digital systems, let's say, which is what Shure is offering, is that they are able to cram more channels, right, within the same space, within the same spectrum, right? So maybe and because analog has got a different way, all right, of managing their channels, all right, because every channel needs a certain space, right, in the spectrum. So sometimes it gets a bit crowded, and you cannot get too many channels within that space that you have.
You cannot manage. You need to compete with certain frequencies.
Yeah, exactly. So switching to digital actually offers you more channel counts in a sense. Right. So of course that part you can explain about that later, right?
Sure.
So yeah, there's a lot of advantage of that. Or maybe you want to upgrade to, or maybe you need more channel count and it says, now I want to move my wireless systems on the network. Okay, maybe I have a large auditorium, I've got multiple rooms and things like that. I want to move the network, right? Maybe my old analog systems can't do that. Maybe that gives you another reason why you want to upgrade. Right? Or maybe you just want something better. All right, better sounding or whatever it is. Okay, so these are all reasons to upgrade. But if you're happy with it, you don't need to increase your channel counts. Everything's fine. I say stick to it.
Right.
There's nothing wrong with it, right?
Good point on that.
Okay. Yeah. Okay. Let me just move on to my slides again. All right. So this is one example, and on this body pack on the right, you can see the details. And let me just blow it up. This is fine. Right, it tells you that it's up to 696. Right. So you're in safe grounds, right? So if you have something like this, I've answered your question earlier. You're happy with that, just stick to it.
Yeah.
There's nothing wrong with it actually,
Agree
right?
with that. Yeah.
Right. If you go to, you can even see on some of the receiver units, at the back of it, they might even have this label that tells you what are the operating frequencies, right? In this case, you got maybe 8 different presets at 8 different frequencies, and the bottom one is at 5 something, right? So first step, identify your systems that are affected by the regulation. Then once you find them, hopefully you don't, right? So that you don't have to do anything. But if you find any of them, right, you should make a change, right? So they should no longer be used, and replace whatever systems, right, they are operating in the affected band, so that you can continue safely, right, supporting your church or your other houses of worship services. Okay. So, and please contact your local distributor for technical support in case you are not able to, determine whether your systems are in the legit band or not, right? So do look out for them. Okay. So, and that's one of the reasons why I'm doing this webinar, because it's a long story, but let me just try to cut it short, right?
Okay.
About 1.5 years ago, I was talking to someone, I think it's Gerald Chu from E&E. I was having coffee with him or something like that, and I was telling him, hey, Gerald, do you know that a lot of houses of worship are still in the dark regarding this regulation, right? And a lot of them have not changed, made the change. When I told them, he says, oh, you need to change it. You need to replace your system. And a lot of them got stuck. He says, wow, I've got 15 sets, with me right now. To make the change is a lot of, budget involved, a lot of money involved.
Yep.
Right.
Yep.
So I can understand where they're coming from. So I was asking Gerald, can we, have this training program again? Right. They need to do it, right? But if you can have a training program that will help them, right, to at least alleviate some of the costs, right? Defray some of the costs. At least you'll kind of help them make the change, right? So that was 1.5 years ago. That was just before COVID. When COVID struck, everything kind of slowed down.
Right.
So I'm really glad that finally we've arrived at this time, right? And then we came up with this program, right? So this is something that Shure and E&E has offered. So really appreciate it. So for houses of worship out there who are looking to change for whatever reason, whether you just want to upgrade or because you're using wireless systems that are in affected band, maybe you can take advantage of this, right? But don't call me, call the good guys at Shure or E&E, all right?
Yes.
So perhaps the follow-up questions may be, right? What or which wireless system should I switch to, right? Because there's a whole, palette of buffet or literally of wireless systems out there. People get confused, right? And then should I upgrade to a more expensive system? Maybe I just answered the question earlier, right? And should I stick to analog or switch to digital? Because I believe there are still analog systems being offered out there, right? Maybe they just want to switch from an affected band analog system to a approved band, but still analog. Okay? Or should I make the switch to digital? Then we're going to talk about that.
Yep.
And then, or should I stick to 47698 band, which is the approved band, or can I switch to 2.4 gigahertz, which is very popular today, right? Everybody knows about 2.4 gigahertz, right? It's everywhere. It's in the home, it's in the office, it's everywhere, right? So, but before we talk about this, let me just cover some very basic fundamentals about wireless systems, all right? So that we can know, what we're going to talk about later. Okay, we call this the quick 101. Okay, so here we have a picture of a wireless mic system and a wireless IEM system, right? But basically they are similar, except that one is transmitting this way and one is transmitting the other way, all right? Okay, so what does it consist of? A wireless mic system typically consists of the following. It's very, very simple, right? We have the microphone element, whether it's on the handheld or the lavalier or the head one, okay? And then we have the transmitter. Right? The transmitter is basically it is on a handheld or on a body pack, right? And then we have the receiver, okay? So that's for the mic system, okay? And then we have for the IEM, which is the other way around, all right? For the IEM, we have the in-ear monitors, which is a listening device. It could be the earbuds, or if you prefer the over-the-ear headphones, whatever it is, right? And you have the receiver. Now the body pack is the receiver, right? As compared to the wireless mic system, the body pack is the transmitter. So it's a reverse role.
Yep.
Right? And the one that you put on your console with the antenna sticking out,
Transmitter.
right, that's the transmitter.
Right.
Exactly. Right. So don't get confused. All right. When you look at the body pack, it says these are the same, but one happens to be a receiver, one happens to be a transmitter. It's very, very simple. All right. Let's look a little bit more into the details. How does it work? Right. So this is a very simple wireless mic signal chain, right? From the point of the microphone where the artist or the person who's using it to the point of the speaker, right, which produces sound eventually. Okay. And so to explain this very simply, sound captured by the microphone element, which is on the handheld or the lavalier, which is like the one I'm using right now, okay, will be converted into radio signal by the transmitter modulator.
Yep.
Okay, it goes in, right? It gets converted, right? But for analog system, right, because most analog system has got a limited dynamic range, right? Maybe somewhere between 50 to maybe maximum 70 dB, maybe, I don't know, right? Somewhere in that range, right? Most of the time, you know, people will ask for up to about 100 dB dynamic range.
Yep.
But you can't transmit that over the analog system. It's just too wide. It's going to occupy too much of the space, right? So you have to compress it first, right, before you modulate and send it out. Okay, so there's this modulation and then demodulation at the receiver end, right? But at the receiver end, they have to expand it back, right? So they compress it, send it over, and then when they receive it, right, they demodulate the signal and then expand it back again to get that dynamic range, right? This whole process is called compending. Some of you may have heard it before, right? But for digital system, it's slightly different, right? There is no need for this compending process. Basically, the signal, the audio signal is just converted into a digital, right? So everything is just converted to 10001110, right? So that's the beauty of the digital system, where it retains that dynamic range, and it doesn't have this compress and expand process, which sometimes, especially in the lower end analog system, they may color the sound, right? They may create some noise along the way, right? So some people tend not to like the sound of the analog, right? But with digital, there is this process where you can almost like say you send an uncompressed signal across. It is what it is, right? What goes in is what comes out most of the time. So that's the digital system. So you might want to start thinking about, you know, oh, now do I go for an analog or digital, right? Okay, so this is how it goes, right? So you go from the microphone to the loudspeaker. That's the signal chain. Okay, let me just go on, right? Then, so this is where I emphasize a little bit more on the analog versus digital. Okay, now, basically both analog and digital have their pros and cons, right? Yes, there are some good things about this and that, okay, but I would say at this point in time, nothing is really perfect in the sense, I can't call anything perfect, but one can be much better than the other, right? So there's some shortfalls, but it's fine, all right? So you're just going to make a comparison, right, based on all things being equal, right? So you cannot compare a low-end, right, analog system or digital system, you know, with a great element and compare it to a high-end digital system or something like that. So all things being equal, probably it says, if I have the same, say, 58 head, right, and 58 head on an analog and a digital, right, what comes out on the other end, is it going to be different? So that's why I'm going to make a comparison here. So, okay, sound quality wise, as I said, generally digital systems can sound better than analog system, right? As far as dynamic range, frequency response, there's less sound coloration is concerned. And another nice thing about digital system is that it's got a higher resistance to interference, right? And but as I mentioned earlier, not all digital systems are built the same, right? Some there are lower quality ones, and you know sometimes even a high-end analog system can beat a digital system, but the price point can be different, right? It could be you need a very high-end analog system, you know, to rival that of maybe a medium range digital system. So the price will be different. So that is something that you have kind of take back and review. Is that something for you, right? So review from the price point, review from the performance aspect. Okay, and then we have this issue about latency. Latency is basically the time delay between the input and the output, right? Like it or not, digital systems will always have some form of latency.
Yeah, so slight.
Yeah, slight. Yeah. Right. But analog is almost no latency, almost no latency at all. Right. So that is the comparison. Right. So people will say, wow, then digital is bad. Right. I'm not going to take any of this digital stuff. Right. But then again, a lot of our stuff are digital today. Right. Our consoles are digital. You know, and a lot of things are digital.
Yeah.
Right. So the good news is that yes, most modern digital systems have overcome some of this latency limitation. Now, correct me if I'm wrong. I'm not sure which system that you have. It goes below like 3 milliseconds or something.
Axion. The Axion system goes beyond 2.9 milliseconds.
Oh, 2.9. Okay, down to 2.9 milliseconds. So that's pretty fast.
Yeah.
Right? What is 2.9 milliseconds to some people?
Yeah, it's almost like seamless. You can't feel it, seriously.
Yeah, okay. I can't demonstrate why it's 2.9 milliseconds here, but it's really, really fast. All right. People usually tell a difference when it hits about 20 milliseconds or 30 milliseconds, right? Where you start to hear an echo. Right. So latency is definitely, there's a difference, but digital systems have come a long way and they've overcome that. Okay. Now, what's next? Then we have channel counts. Right. One of the great things I've learned about digital systems is that you can squeeze more channels within the same spectrum. Right. So if you are looking to add more and more, I mean, that's growth. Right? Because every year it says, oh, I got new programs, I got a new venue, I got a new room somewhere, I need more channels, right? So digital can help squeeze a bit more, right, over the analog. So this is something that you want to look out for, right, in case you want to upgrade your current analog system, right? And security, I mean, this is not something that people will ask most of the time, but being digital, some people will say, can I just hack into your system, right? And I'll hijack it, you know, I'll pump my voice over the system and things like that, you know, and, you know, it's not you speaking, it's someone else speaking and things like that.
I think this is a very good point also.
Yeah.
So you highlight, because based on you know, our exposure with clients, especially we talk about the government sectors.
Yes,
talk
exactly.
to, you know, all those institutions, education especially.
Yeah.
And moreover, right now we transition ourselves, so-called is a new norm. You can see that everything transition into soft codecs. So security is very, very important.
Exactly.
So I think this is something which is a future proof. That's a good point to highlight off regarding about, you know, digital wireless mic systems.
Yeah. So security is definitely a high point. All right. So do consider that. So there are a number of pretty good advantage, right? So now that you've heard of this, review and see if there's a need that you have, right, in your application. Okay. So let me jump to 2.4 gigahertz now. Okay. So what you see on the slide is a 2.4 gigahertz on the right, and you have the standard UHF band 470 to 698 wireless mic system. Okay. They look almost the same. Basically, that's what it is. And 2.4 gigahertz is something that's very, very common today. So question, right? Because both are being offered. In fact, Shure has both, right?
Yes, we do.
In fact, there's one band I didn't even highlight here, which is the DEC system 1.9.
So it's 1.9 gigahertz.
Yeah, which is exactly what I'm using right now. This is 1.9, right?
Yeah.
Sorry, the transmitter is on my table. So, but let me just focus on 2.4 and the standard 470 698 band, right, which is very common. Now, question is, should we switch from UH band to 2.4 gigahertz, right? Because people may see something great about 2.4 gigahertz, which I'll explain a little bit, right? Well, should we switch to that? Would it be a good alternative, right? Would it be the same? Is there any difference, right? Because you'll see that there are some advantage of 2.4, right, that people may find very attractive. So people might just rush into, you know, just buying 2.4 if they need to change their existing system. But wait, right? Just hold on. Let's study and what's the difference between the standard UHF and the 2.4 gigahertz. Right? So what do we have here? Now, in case you don't know, 2.4 gigahertz systems basically operate between 2.4 or 2.400 gigahertz to 2.483. You know what this means? It means that there's actually only 83 megahertz available space, right, for the 2.4 gigahertz system. Okay. Now, what does that mean later? I'll show you. Okay. Then, like the digital and the analog system, both have their pros and cons.
Yep.
Okay, let's look at maybe the good things first, right? So what are the pros of a 2.4 gigahertz? Now, most of the time, a lot of people cannot tell the sound quality difference, right? For most users, right? So if I were to do an A/B blind test comparison, a lot of people can't really tell the difference, right? Unless you're very critical. I'm sure there are people that you know that are very critical, right? You can tell, oh man, I can tell what it is. It says, great for you, right? Good for you. But most people can't really tell. So it will apply and will be good for most applications, right? Then we have this thing about 2.4 gigahertz systems are usually simpler and easier to operate, right? A lot of presets, not too many channels. They can need to tweak around and things like that. Very, very simple, right? Operation. So very, very friendly to use. Okay. This is a very nice plus point. Most of the time, now correct me if I'm wrong, right? I haven't seen the prices from Shure, but I believe the 2.4 gigahertz systems are priced slightly lower than the UHF band. Is that correct?
Yes.
Generally, yes. Yeah.
Slightly lower?
Slightly lower.
Yeah, so people may find that, wow, this is more attractive, okay? Which is a good point, right? But again, don't rush into buying it, right? So 2.4 gigahertz can also be used practically in any country. You can take your system, go to any other country and says it is legal to use it there, right? Sometimes you can take our 47698 system to another country and says it is not legal to use it there. That is possible, right? Because not every country has the same regulation.
Yes, correct.
Unfortunately, right? But 2.4 is an open, right, spectrum that you are free to use anywhere in the world. Right. So that's a nice thing. So if you want to travel with your wireless to Spain or whatever it is, right, you want to be a performer there, it works. Right? Nobody's going to chase you, right, for that. But that's fine. So these are really nice things about 2.4 gigahertz. Now, if you look at the cons, all right, are there cons? Well, maybe I shouldn't call it cons, just difference, right? Now, as you can tell, there's only the 83 megas range that you can play with. Most of the time, it is very difficult to fit more than 12 channels, right? Some systems from certain brands can only fit in 8 or 10 maximum, right? So if your venue requires more than 8 or 10, it says, can I go to 15 or something like that? Nope. At this point in time, you can't.
And you have to take consideration with competing with the routers we have.
Yeah, exactly, all right? So, which is my next point. So UHF has got a lot more channels it can offer, right? So there's something that you really want to consider. Now, think about this. If today, when you do your wireless planning, right, and you do your channel count and says, okay, today I need 8 channels. That's all I need, right? And it says, I can go out there and buy a 2.4 gigahertz, assuming my other devices doesn't interfere with my system, right? That's fine. But you cannot think about what you need just for today, right? You got to think about the future. Yeah, you got to future-proof, right? So just adding 1 or 2 more is going to be a problem. So that is something that you really need to think about, right? If you think that you're going to need more than 10 channels, right? It goes on to 15 or even 20 channels, right? Within the same space, right? The same space, it could mean not just the room itself, it could be your neighboring rooms, right? They are also using wireless systems because they're all in close proximity. Right. So you need to take that as a single system and then consider your number of channels that you need. Right. So if you have that kind of requirement in the near future, then maybe you should just go straight to the UHF band.
Agree with that. Yeah.
Right. And yeah, the 2.4 is great for small use and things like that. Okay. So again, as you mentioned, 2.4 is actually very crowded today. Right. We have a lot of Bluetooth, Wi-Fi devices. They're all operating on the same band. Right. Now, it doesn't mean that UHF band is free from interference, right? There's no such thing that is free from interference, all right? But that is something that you can manage, right? But if you take your 2.4 gigahertz device and go into a space that is a common space, right? You cannot change the environment, right? You got so many things running, right? All your routers and so forth, all your access points. So the UHF band, you have a little bit more free play. And like I said, there are more frequencies to play with, right? So 2.4 is pretty crowded. So do take that into consideration. I've got, some churches call me up. In fact, there was one I can remember very, very distinctly. This is very, very interesting. They call me up and say they have problems with their 2.4 gigahertz system. I think they have about 6 or 8 units running simultaneously.
Okay.
And they tell me that during rehearsals, which is like a Thursday night or something, it works fine. No problems at all. Everything is smooth. Everything is great. You can see the RF meter is fine. It's full. On Sunday, it goes haywire.
Oh my God.
It goes haywire. And they say they find it very strange. So I went down on Sunday and says, yeah, this is strange too. Why is this happening? I realized, wait a minute, this is 2.4. And I says, wait, the members, they lock in to the church system and the Wi-Fi.
Okay.
Right. So there are like 300 members or 400 members. We have to lock in during service, either to read announcements or something. So the amount of traffic that's going on in that room is pretty immense. Right. So
I meant for the sound.
Yeah. So that's why it happens only on Sunday and not on a rehearsal day. Yeah. So these are things that you want to think about. Right. These are all real life experiences.
Yes.
Yeah. Okay. And what's next? Yeah. Okay. Now, given the same transmission power, right? Let's say both are 10 milliwatts. Right. This is what I have encountered, and I believe some users have encountered as well. UHF systems tend to have a slightly further operating range in terms of distance, right? Like for example, if a UHF can go to 100 meters, right, or 300 feet, whether you go imperial or metric, right? Typically, a 2.4 may go up to maybe 60, 70 meters max, something like that.
It's about there.
Approximately.
Approximation.
Yeah, it seems like that. Yeah.
In terms of UHF, working range is definitely longer.
Yeah.
Or further compared to the I would say for 2.4 gigahertz.
Yeah.
Yeah. In terms of working range.
Yeah. Okay. So thank you for your answer. Right. So to sum it up.
Yeah.
Okay. The bottom line is this. Right. If you need only a few channels, right? Maybe less than 10, maybe 8 or less, right? And you have a relatively short distance space, right, in your room, small room or small auditorium. You want something that's simple to use and a slightly lower price point. 2.4 gig will work wonderfully most of the time, assuming that your other devices doesn't interfere with, right? That's fine.
Okay.
In fact, I personally own a 2.4 gigahertz, which I carry around with me when I do my training, right? Because I do it in the classroom or in a small space, it works fine, right? No issue at all, right? But if I were to do a show, right? If I'm going to do a concert and things like that, I would think otherwise, right? I would prefer to go straight to a UHF system, right? Where you can have a lot more channels, you get a much longer operating distance, and you get good sound quality and system stability.
Okay, one thing regarding about this, right? So we have discussed regarding about 1.9, 2.4 UHF. So perhaps member on the floor, they have these questions due to current pandemics.
Yeah.
How do you see it, right, with uncertain situations? We have a pandemic, we're not going to know in the futures, and the vast changes of technology as well. So how do you advise, Robert, regarding about, to all those participants, members on the floor of House of Worship regarding about the system proposals? There are so many, 1.9, 2.4 UHF. So which is right with the current circumstances? How do you see that?
Good question. I can only answer it this way, right? It is very difficult for me or anyone to say, right, what's going to happen in 5 years from now, not to mention 10 years, right?
Yep.
As you can tell, just about 1.5 years ago, everything was fine. Shows were on, concerts were on, houses of worship were free to, have their services week after week. Week after week, everything was fine.
Right.
And then boom, the pandemic came.
Yes.
Right. And then the whole world basically swing into a different mode of operation. Right. Streaming was never an in thing at that time, and now the whole world is streaming, which is what we are doing right now. All right. I do face-to-face training most of the time, but now I am reduced to a camera. Camera. Right.
Yeah.
So what is the best thing to do? All right. I think the best thing to do is to ensure we are able to adapt quickly, right, and the right way, right? And that's the reason why we need to upgrade ourselves, not our equipment, just our equipment, but upgrade ourselves. You know, so for me, I've attended so many webinars and trainings, you know, just to keep refreshing my understanding of what's happening in the world, what's being updated in the technology, right? So that when I service my clients, right, or as a user, at least you can kind of think, this what's the next thing, right? Is what I'm using now an old technology that might be obsoleted, right? Would you? That's why we talk about 2.4. We talk about digital systems, right? Do I move from analog to digital? Is there a need? So these are things that we can learn along the way,
right?
Right? With this information, when you're armed with this information, you make a informed choice, right, about what you do, right? Because these are, at the end of the day, investment, investment that you have to be using for the years to come. It's not something you buy today and tomorrow you discard. Hopefully not, right? So that's why we need to get smart.
Yes.
Right. So my advice is that, you know, you should keep abreast of what's happening in the world.
Yep. I agree with that because regarding about, you know, definitely everybody has been informed, you know, has been educated. So the things that, I don't know, depend on your experience, perhaps, Jamie. So how do you see is like, you know, common mistakes from clients, regardless, you know, especially we don't mention anyone or system integrator itself regarding about the wireless mic systems. How do you see that? Even though there's a lot of educations came out, especially during pandemics, right? We give a lot of manufacturers, a lot of partners give out a lot of trainings. But how do you see, you know, the common mistakes from, you know, all the markets or clients?
I see a lot, right? Unfortunately, but let's focus on the wireless.
Okay.
So if you ask me, are there mistakes commonly committed, you know, on wireless system? Yeah, it can be anything. It could be the wrong cable being used, you know. I think Shure recommends that they should always use 50 ohm cables for the antennas.
Not video cables.
Yeah, not anything
25.
that's be connected to a BNC is the right cable, right? It doesn't mean that, right? But
I feel the frustration.
Yeah. No, I've seen people. Okay, this is not a fake story. I've seen people use electrical cables for mic lines.
Oh my.
Right? Yeah. So because to them a conductor is conductor, a wire is wire, right? So yeah, so there are contractors who do that. Unfortunately, hopefully there are very few of them. Then of course there's wrong placements of the wireless receivers, you know, antennas and so forth.
Right.
I think that's one of the biggest mistake because I've seen not only in houses of worship, everywhere. All right. It could be in schools, especially in schools where they have wireless receivers placed at the worst awkward locations. And then they ask, why is there so many dropouts and so forth? Why are my signals, you know, keep falling in, you know, falling out and things like that? So I think that's one of the biggest mistakes committed. So let me just quickly move on to, yeah, exactly. This is the point I want to bring across.
Okay.
Right. Let me just talk about wireless dropout. Now, wireless dropout is one of the most irritating things that can happen when you're using wireless, right? It is like you hear me, you know, speak a few words, and next moment you don't hear me anymore, and the next moment you hear me again, right? Especially when I walk from the left side of the stage to the right side. So you hear me, then you don't hear me, then you hear me again. So those are all RF dropouts. Now, what is causing that, right? So RF dropouts can be caused by many things, right? And most commonly, it'll be antenna placement, antenna distribution systems that are not done correctly, or maybe even frequency selection in the cable selection. Okay, but let's talk about antenna first. Okay, now, so what I've listed down is a few things that every user need to know about antenna system and how to use them properly. Right. So I think maybe most people have come across this term called diversity for a very long time, but never quite understood what it is. And until today, I encounter people who do not put diversity in you know, they do not use it in the right way. Okay, so what is diversity? Now, most receivers will have two antennas. Okay, today, right? In the old days, yes, you have a single antenna, very common. You know, when I first started out, long time ago, I wouldn't say when it is. Yeah, long time ago, it's still a single antenna, long one, very long. You know, just extend out, right? But today they are mostly two antennas. Now, what is two antennas for, right? Okay, that's what we call a diversity receiver. basically there are two antennas that are working on independent antenna systems. So the nice thing about it is each antenna is always looking out for the best signal, right? And then it selects depending on the manufacturer and how they design their systems, right? They got different algorithm for selecting which is the better ones, right? So let's look at this simple graphic here. Now, if you have a single antenna, which is called a non-diversity, right, receiver, single antenna. Now, the antenna is receiving signals from the transmitter, in this case, a handheld microphone, right? And you think that it is only receiving signal directly from the transmitter. That's not true, right? Especially in an enclosed space like this, right? And a lot of the signals that's arriving at the antenna could be coming from other places like reflection from the walls, the ceiling, and so forth. But the problem is that the antenna doesn't know, right, which is the right signal to accept. At the end, it accepts everything, okay? And when that happens, that single antenna, they have no choice but to take everything, but it is probably a sum of all the signals arriving at, but that signal could be a damaged signal, right? Because there's a destructive interference, right, due to a signal that's coming in on phase, and then with the reflection coming in, could be out of phase, right? And there could be multiple of them. And in the end, you get a very, very bad signal. Right. Either you get a complete dropout or you get a very weird sound coming in, right? Because everything's really messed up already. So with a single antenna system, it works like this. But with a true diversity system, you have two antennas. And if you get a very good quality wireless system, right, they're built into the algorithm, a very smart system where it can tell which is the better signal to use, right? And if one is getting a lot of junk coming in, right, it will switch to the other antenna. Okay, that's how it works, right? So the two antennas are very important. So if you have one antenna broken for some reason, please get it replaced, right? It's not like there is a just in case, right? Yeah, it's not a redundancy. It's not a redundancy antenna. Okay, both antennas are in use 100% of the time. Right. Okay. So following on this point, so let's look at this, right? So this is a very common receiver setup. Now you have one on the left with like a V-shaped antenna orientation, and the other one is two parallel chopsticks. Like what chopsticks? You call it chopsticks? It is fine, right? Yeah. So if you ask this question, which is better? Do you put it upright like this or put in a V shape or something like that? Okay. A lot of people may not know because I've seen random positioning of antennas all the time. Some like this, some straight, some cross. I'm not sure what it is, right? So where are we going with this? Now, the better way to set up the antenna is the one on the left, okay, which is what we call the polarization diversity setup, okay? Now, what is this polarization thing? That's what I'm trying to explain to you, okay? So let me just quickly move on. Now, this thing called wave polarization. Now, from the transmitter antenna, right, you have this wave that's coming out, which is electromagnetic wave, right? Now, polarization basically describes the way electric field of the radio wave is oriented. Let me show you how it is. This is what it is, all right? So it's got the electrical field plus the magnetic field. Now, what's important is that you have to align the electrical field, right, to be on the same polarization as the receiver antenna. So in this case, it's vertical versus a vertical antenna receiver. Now, this is great, right? This works. It's the same thing for a handheld, right? Now, with let's say you put an antenna this way, that's not going to work, right? You're going to lose a lot of signal that way because you are not aligned between the transmitter and the receiving antenna. Okay. So let me just quickly show you this nice little graphic. All right, I think it was done by Shure or someone. Yep. I think it's done by Shure. Yep. Yeah, very nice experiment. Right. So what they did here was that they measured the signal. All right, they measured the signal with the antenna upright, and then they get the handheld, right, just transmitting at different angles. Now you notice that with the antenna upright and with the handheld almost at a 90-degree orientation to the antenna, you will see there is up to a 15 to 16 dB signal loss. Yep. Right? Now compare that with this when you orientate the antenna in this what we call polarization diversity setup. Okay? How you angle the handheld transmitter, right, whether it's vertical or horizontal, you see that the transmission loss, or the signal loss rather, right, on the left side, right? It drops to probably a max of 2.5 to 3 dB, right? So by orienting the antennas in a V shape like that, basically like a 90 degrees, right? You will minimize the signal loss, right? So the best way to orientate the antenna is like this, not upright, or both, parallel or something like that.
Yep.
So this takes care of, users of handheld, they don't hold the mic. Okay, I got a handheld here, right? So assuming this is a wireless mic, right? Nobody holds the mic vertically all the time, right? This is nobody does that. No human does that, right? They'll tilt the microphone anyway. So when that happens, right, the field changes, right? And then you get a signal loss because of that. So you need to orientate your antenna, right, to take care of this. Okay. So here's an example, a really bad example, right? And you see that the antenna is pointing out like that, out, right? This is a really bad antenna placement orientation, right? Sometimes you ask the user why you do it this way. He says, "Isn't that great? I'm pointing my antennas towards my transmitter. Isn't it right?" Right? Yeah, I get responses like this.
Yes.
Right. So this is where sometimes people's, they get a misunderstanding of how antennas work. Right. So this is wrong. And what makes it worse is that this is inside the rack.
Yes.
Right? That makes it even worse. Okay. So let me talk about this thing about obstruction. Right? This is a very famous graphic. This used everywhere. Right. Now, guidelines of where to place receiver antennas. Firstly, there should be no obstruction between transmitter and receiver. That's a clear cut, right? You should not block the signal. They try to put it free from any metal objects or structures. They keep it away because they tend to reflect or absorb the RF signal. So don't do that, right? Place it minimum 2 meters above ground or above the standing audience, right? Because people is human bodies rather. We are made out of liquid. We are all like what 70% water.
Yes.
Right. We absorb RF.
Right.
We are a RF absorber. That's what it is. So sometimes, wireless performance tend to degrade when the hall is full of people compared to an empty hall. That kind of thing can happen.
Yep.
And please orientate your antennas properly. And of course, do not place receiving and transmitting antennas, like in your case, like IEM and a wireless mic, right? Don't put them close to each other, okay, because they interfere, right? Now, this is a example that, this is my example actually. One church called me up and said that they are having problem with their wireless, getting dropouts. Okay, they asked me why. So I went to visit them and I saw this. Okay, so this is actually here. Okay, so it's inside the rack. Not facing the stage, inside the metal rack, which is terrible. And this metal rack is inside a room. It's basically a disaster, right? For RF equipment. Okay, so no wonder that they get dropouts. It's amazing that even get any signal.
Yeah. It's
right? So yeah, RF is really a very good dropout is really a very good thing. Okay, then this is another bad place to put wireless receivers behind the wall, things like that. Again, you are very fortunate that it works, but don't count on it all the time. Okay. So what do we do, right? So we have this thing called antenna distribution system, right? And what are these, and when are they required? Then I'm going to talk a little bit about different antenna types. Okay. So here's an example of a antenna distribution setup where we have 4 receivers, right? Sharing just a pair of antennas, right? So, and then we have the distributor right on top. So instead of using 8 antennas, right, now you're just using 2, all right? And these remote antennas, as we call them, can be positioned anywhere in the room, right? Not necessarily at the receiver itself. Now, if you have more than 4 receivers, you can cascade, more units together. In fact, you can go up to what, 16.
As many as you want, actually.
Yeah. I think there's a step. There's a limit, right? And like 2 layers or something like that.
You can mix the distributors up.
Yeah, exactly. More, right. So if you have only 8, right, you can use this, or 16. Now, when do we use antenna distribution systems, right? When are they typically used? Okay, if you have 3 or more wireless systems, that's when you start thinking about using distribution system, right? Because you can't place them far apart, right? You're forced to stack them. I'll show you in a picture in a while. Okay, when there are obstruction between transmitter receivers, right, and then you got to put your antenna somewhere else. and you have receivers that are positioned in a room or in a console somewhere, right? That you're going to get problems with RF. So this is a classic example, right, where they stack antennas or receivers like that. That's not a good thing to do, right? Let me show you an even more terrible example.
Wow.
Okay, please don't stack receivers like this and put antennas next to each other, especially when they're parallel to one another.
Yeah.
Because they all interact with one another, they interfere with one another. Okay, so if it happens to work for some reason, right, be ensured that at least your operating distance have been affected, right? So yeah, don't count on this.
So Robert, we have a question that just came in regarding this exact scenario.
Yep.
So this user was asking, how do I put my receivers in a portable rack, given that the antennas cannot be positioned properly? So I think you addressed this point right on the spot.
Yeah. If you have a mobile setup, you can put your receivers in the rack, which you can push around, and then your antennas you can actually mount it up on like mic stands or something.
Exactly.
Right. Yeah. Then there'll be a mobile setup.
Yep.
Okay. Right. Let's go back. So let's talk a little bit more about this. Okay, we got a whole variety of antennas that you can use, right? In fact, I think Vic, you got some on the table that you can show.
Basically, we have few type of form factors for wireless mic systems. Basically, is you can see over here this white color that we have few of the antenna form factors that you can suit with the aesthetic. So, for example, some clients, they say they want to have something which is my wall is very important. Anything just have to ensure the aesthetic is cool. So we have something which is like this. You can see you can paint it as well. We have something which is a plate for you to paint it over on the antenna. In the meantime, let's say I think it's the standards. You can see this is another type of antenna. It's a directional type of antenna.
Yeah, I use a lot of that.
Yeah, so you will see that if those who is going to concerts, live sounds, even you go to MBS, you can see this type of setup from the boys. They set up this type of antenna. This directional antenna is one of the consideration as well. By default, when you purchase wireless mic systems, you will have definitely it's default. You come with one pair of antenna. So this is a half wave type of antenna type for you to mount it, at the receivers. And for the PSM systems, we have show it over here.
Oh, this huge thing here.
Yeah. So let's say you require some of the PSMs, systems to have a wider range. So these are the antenna that you can mount it a remote area in order for you to have a better coverage or certain distance. So all of the products that we have is calibrated based on the client's needs and their designs.
Great. All right, thank you. Oh, thank you for the show and tell here. Yeah, these are really nice. I use a lot of them for many years already.
Shark fin.
Yeah, they call it pedal or fin or something like that.
Right.
Okay, let's go back to the slides. So now one of the advice that we want to give you is that try to stay away from very strong RF sources, like walkie-talkies and stuff like that. But recently, right, this thing is very, very common, right? More and more places are installing LED panels, LED video walls, right? Especially the large ones, So there was one project I did where they had an 8 or 9 meters wide screen. That was a number of years back, right? And the next moment, the performers are complaining that the wireless IEMs are not working.
Yeah.
Right? Yeah.
It's bad.
I said, oh no. All right. So most of the time it could be caused by the LED video walls, all right? Because the performers are standing right in front of the screen. Yeah. Right. If let's say they are a certain distance away, maybe because of signal drop, things like that, you wouldn't interfere as much, but they're standing right in front. Now, so be careful about this, right? Whether it's wireless IEM or wireless mics. Well, the good thing is that a lot of LED video wall manufacturers have improved their designs, right? Possibly they have improved their power supply, they could have improved their shielding, and so forth. So recently, I've been getting less and less problems, right? But for anyone who is going to invest in both wireless equipment and at the same time you're investing in the LED video wall, do take note of this, because there could be a possibility there might be some interference in between.
Yep.
Right. So be careful about how you install them or where you install them. Right. LED video walls are great. Right. Just make sure you stay them away from wireless systems. All right. Okay. right? So this is just another measurement that was done by someone, right, where they measured the spectrum, right, without the LED video wall. You can see there's this the operating frequency spike there. Then when the moment you turn it on, right, the LED video wall on with no image, right, you can see all those spikes coming out. Okay, those are potential interference with your wireless systems. And the moment the image is turned on, right, it just raises up all the noise floor and so forth.
Yeah.
So these are all potential causes of interference for your wireless. So very, very important, right? So do take note of that. Hey, let me just move on to the last point for tonight, right? I'm just going to talk about battery options for wireless systems. Some people may find this very strange. It says, why is this even important, right? In my experience, right, I was a live sound engineer for many years, right? And wireless system is definitely one of the many things that I use, right? And at the same time, I work with other users, and I encountered that batteries could be the weakest link in your wireless system, right? To me, you can invest in thousands and thousands of dollars for your wireless equipment, and then you put in a very low quality, battery.
Yeah.
Right. Recently, I was in a school teaching, the AV people, and I was using this handheld wireless, and they put in some batteries, and they told me it was brand new, right? And it lasted me
15.
An hour or so. That's it. And I was teaching halfway, it what happened to my signal? My sound got cut off, and the whole transmitter died. Batteries, right? They were putting the wrong battery, and I'm going to talk about batteries, right? More details. So battery options for wireless systems. Okay, what options are available and which should we use for wireless systems? Should we use rechargeable batteries? When, why? Right? And other rechargeable battery options, right? So let's talk about what options are there. Typically, we know there are a lot of single-use batteries, which we use all the time. It could be anything for your shaver, for your toys and so forth. So single-use, right? We have the standard dry cell. Okay, the standard dry cell as opposed to the alkaline that we're also used to, right? So please, if you value your event and you want to use your wireless microphones or IEMs, over at least a good period of time, right? At least during your program, right? Try to stick to alkaline, right? Because the standard dry cell may not hold enough charge, right, to last that duration. So the alkaline is going to last you longer, at least maybe, I don't know, 6 hours, 8 hours or so, depending on your wireless system. But if you use a standard dry cell, it could mean that you will have a very short event, right? Speak halfway and suddenly
Very bad things going to happen.
Yeah, exactly, right? So if you value your show, value your event, please stick to alkaline. Or you can use rechargeable batteries, right? Rechargeable, it started off, early days with nickel cadmium, all right, which we know that it's not very good at the end of the day. It's got low charge and it's got memory effect. One of those things, right? And then it tends to lose charge over time. Then we move on to nickel metal hydride, which is something we're still using today, which is much better, right? It's not supposed to have memory effect. It holds a higher charge and things. And then we have lithium ion, which is great. And a lot of things are using lithium ion right now. My laptop using lithium ion, right? Even mics are using lithium ion, right? So these are the better grade rechargeable, right? So should we use rechargeable batteries and why or when? Okay, so one thing is cost saving, right? If you're going to use it on high drain devices, right, which I consider a wireless mic is a high current drain device, right? Because you put in a battery, you use it over hours, you die. Okay, if you put a AA battery alkaline into a clock, it will last you for months or I don't know how long, right? So that's our low drain devices. So in cases like this, if you're going to put it on a high drain device, you're going to reuse it several hundred times because rechargeable batteries can go several hundred times, right? Depending on which type of battery you're using, you can go 300, 500, some even claim 1,000 cycles, depending, right? So there'll be a considerable cost saving as compared to single-use batteries, right? And of course, if you care for the earth, all right, you'll be more environmental and resource friendly in the long run, right? And you don't have to, run to the shop every time you need to buy disposable batteries. Okay, so convenience. Now, when do you not use rechargeable batteries then? Okay, The reverse is true, right? For low drain devices that take many weeks or even months to drain the battery, it doesn't make any sense to use rechargeable batteries. So in our case, we do, right? And also, I will always advise that you use high quality, not only high quality rechargeable batteries, but high quality chargers, right? I know a lot of people who are using cheap chargers, right, who do more damage to the batteries than ever. They think all chargers are the same. Unfortunately, it's not true, right? So if you invest in good quality batteries and chargers, that would be a relatively high upfront cost. Okay, so some people may not be willing to do that. So if you're not going to use the rechargeable batteries frequently, regularly, then maybe it doesn't make economic sense, right? Stick to your single-use batteries. And this is the last thing that I want to talk about, right? I've encountered so many times where I go to, whether it's a house of worship or event company and things like that, and I'm out to run an event. Says, can I have the batteries? So, sorry, they're not charged. Says, what do you mean they're not charged? I got event in starting in half an hour. What do you mean the batteries are not charged? So I ask them, do you have disposable batteries? No, we need to run out and buy.
Oh my
So
God.
can you imagine I'm running, say, a service at 7 a.m. in the morning. Just where are you going to buy batteries now? Where's the nearest 7-Eleven, right? So supermarkets are not open. So these are things. So if you have a team that lacks the discipline and don't manage the batteries properly regularly, right? And then I think you're better off with disposable batteries.
Yeah.
Right. So rechargeable batteries needs discipline. You need to take care of them. You need to make sure you charge them frequently, right? And you drain them accordingly, right? And I know that even Shure, right, and many other good manufacturers comes up with their own rechargeable solutions, right, and things like that. So what are the good things about them is they're more convenient, they're controlled and predictable battery performance, right? And they've got a lot of nice features which I like. Some of them even tells you your battery health, there's an overcharge protection, things like that. And some higher end models even have network remote battery monitoring. Yeah, I've seen many of them.
Thanks, Robert. Regarding about sharings, regarding about how crucial is battery it is, rechargeables. Then after that, with what is the situation you use for lithium-ion batteries as well. So just to add on further regarding about our systems. So our form factors is very unique, be it for UHF, 1.9 gigahertz, 2.4s. So some of the form factors of the system design you can see over here. For example, this one you have a few of this is 2-bay. So this 2-bay is meant for 1.9 gigahertz systems that are compatible with different type of form factors, handheld, belt pack. Then these are the systems that we have. So you can see cute little charging station here. So this is meant for UHF. That this is 2-bay. So you can just dock charge, just put it on this, or perhaps you want to take out batteries. You can see here this is lithium ion.
Yep.
So lithium ion is uniquely become with 1000 life cycles, so batteries. So you can really just plug the batteries into it, then you just charge it. And the best part about our digital wireless mic systems, some of our 2-bays, 4-bays, and 8-bays for UHF charging station, it comes with network functionality as well. So what is the cool part about I would say network? Because right now, due to pandemic, you can see the situation, people want to have a remote monitoring.
Yeah.
So that's where that we have a functionality that not only you can really monitor the battery, you can see the life cycle as well. So some of the batteries,
That's
if
very
they say,
important,
some of the our transmitters that you can put, disposable batteries. But disposable batteries, based on our system, you only can see the battery levels,
Exactly.
3 bars, 2 bars, or 1 bars. So if let's say with rechargeable batteries from Shure, from our side, you can see, how much is the depletion time. So this is a cool part I would say is critical. For example, education institution, you cannot afford to have this kind of, for example, you say lack of management. Perhaps the guy is like, this is last month, he's not going to do anything about that. But you need to have this kind of management.
Exactly.
It's very crucial about that. And you can see at the front here, we have PSM systems. Some of our PSM, or we call it in-ear monitoring systems, that is compatible with rechargeable battery mode as well.
Oh yeah, I see it here.
Yeah.
This is charging.
Yeah, this is a dock charge. You can just charge it on our 2-bay or for the system charging station systems. And uniquely, if let's say for touring, especially, or perhaps some of the churches or some of the house of worship, mosques, they want to make this different type of event. So we have This is where just now we just mentioned regarding antenna distribution systems. And our receiver, we have few type of form factors: single channels, dual channels with one chassis, or quad channels.
Yeah.
And you have additional digital audio. If let's say they want to upgrade into future-proof systems with Dante, AES3, all those stuff.
Yep.
So yeah, so these are choices, I would say, for the clients and to manage their systems. And right now, to us, for wireless mic system is an investment type.
Yeah.
You know, because these are the investment and equipment that you need to be used, for example, for event. It's a ROI, I would say. So based on house of worship, I would say go for a good investment.
Yep. Definitely. Yeah. Yes. Invest wisely.
Correct.
Yeah, that's very important.
Yeah.
All right. Come back to the slides. The last point here. Now that we know that the various types of batteries available, and especially the rechargeable type. Now, if you're going to use rechargeable type, then you need to make sure that you maintain the battery health, right? To give you much more stable, much more longer life, right? Okay, let's look at what do we need to do, right? As I said, use only good quality, reputable batteries and chargers that are designed for the specific battery type, right? Don't buy one battery, maybe Shure, and then, oh, can I use something that I bought online from somewhere else and charge your batteries? Better stay away from that.
Yeah.
If you don't want to catch
Best
fire,
practice.
things like that, you know what happens, right, with batteries, right? Yeah, and then please do not overcharge them. If you have a system that auto shuts off when fully charged, that'd be great. If I look for it, right, it is good to use the batteries often. Again, if you don't need to use rechargeable, stick to disposable. But if you use them regularly, yeah, it's good, right? It's also good to practice this thing called discharge cycle, especially if you're using nickel metal hydride. Even though they tell you there's no memory effect, right? Based on experience, a lot of users come back and say, every now and then, maybe a few months, right, try to do a full discharge and recharge them again, right? You realize that it gives the battery a new lease of life, right? And if batteries are really not used for long duration, maybe like during COVID, right? Unfortunately, a lot of events cannot be held, right? A lot of companies are not using their wireless mics. So if you're using rechargeable batteries, you can store them, but make sure that they are stored with at least maybe 40% state of charge, right? It will at least keep the battery in good working condition,
right,
and allowing for slow self-discharge. Because when you keep rechargeable batteries over long duration, they will still discharge. But imagine you just put in 5% left, and then it just dries out, all right? And then you realize the next time you use them, it doesn't work anymore.
Right.
So be very, very careful about that. All right. So I hope I've given you some good pointers about wireless systems, and
Yes,
yeah, that ends my presentation.
Yeah, thank you, Robert.
Most welcome.
You covered a lot of topics today, and I think at the end, I think I see a lot of questions on batteries coming in.
Oh, really? Okay.
Yeah.
Wow.
Yes.
A lot of battery
I
questions.
hit the nail. Yeah.
Surprising regarding about
Yeah,
batteries.
yeah, batteries.
So
right?
of course, among others, there are other questions, but it's just when you talk about batteries, there are many that came in suddenly. So, but I think to summarize what people are asking from the audience, I think one of the main questions is about portable receiver racks that I think you have already addressed.
Yeah.
So I think one of the main things is to actually, of course, I think some questions that came in is whether can you still stack it, but does that affect somehow? So I guess the best way to do it is actually you can still stack it,
Yes.
but just use a proper RF distribution,
Yes.
have your antennas pointed right at where you want to operate.
Yes. Yes.
Right. And then be in the same hall as your operation so that you don't get any, dropouts, for example.
Exactly.
Yeah.
Yeah. In a lot of hotel ballrooms, right? You don't put the wireless receivers in the ballroom itself.
Yeah.
They're in some control room somewhere.
Exactly, yeah.
So you can't stick the antennas in those rooms. It will never work.
Yep.
So the antennas have to find their way into the ballroom itself.
Correct. Yeah.
Right. So whether it's for school halls, it applies the same, right? So you can stack them, but it's how you manage the antennas.
Exactly.
That's the most important.
And I think as Vic mentioned also, there are many form factors for antennas, including wall-mounted ones, including the huge conical types and directional types. So it fits all aesthetic, or interior designs, for example, for your sanctuary, for your, places of worship, for example. So it basically blends in well overall.
Yeah.
Few things that I just realized whenever we try to explain to the clients, a very simple analogy that I do is, for example, whenever you want to use your Wi-Fi, for example, your phone, you want to access a Wi-Fi, you need to know that the router must be close to you. So similarly, just like this type of ideas, I just share with clients. If let's say you want to have your systems, wireless mic systems, you need to have within a line of sight to cover up your transmitter. You know, that is a simple analogy I always use. So I hope this message really can send across to all of the members of the floor.
Yep.
So this is a good point.
Okay. You brought up a good, very important point. Be very careful when you use the term line of sight, right? Because I can bend that rule. Like for example, if I have an antenna here, right, and my performers are out there, right? Line of sight means I can see from here to there or there to here, right, with no obstruction between. But what happens when I put a metal fence right in front? Right? That is going to mess up the RF signal.
Yep.
My antenna can still see the transmitter.
Interpretation, they thought is line of sight.
Yes,
I
exactly.
forgot about that.
The metal fence is going to mess up.
Yes.
All right. Then you find that depending on how big the openings are, right, and depending on what kind of material, whether it's steel or copper or whatever it is, right, it's going to affect the amount of signal that's going to hit the antenna. Right. So be very careful. So the best is nothing in between. Right. Even glass. Okay, glass is just a little bit, right, or effect on antenna, still line of sight. Right. So be careful about that.
Right.
Yeah.
So while you were also talking about the LED walls, we did mention about the interference portion. So questions did come out about, okay, how do we, analyze what is good? How do we see if, are we competing for the same RF space? So is there a tool that, we can use to actually measure how, how the wireless mics are actually spaced out, in the RF space? Yeah.
That is not something that I do, all right? And I'm going to push the responsibility back to the guys at Shure, right? Because they have the right guy. I mean, you have the right equipment, and you can actually go down to the space and do a scan, right, to check.
Right.
And I don't own that equipment. Unfortunately, I would love to get one. Cost me too much, but yeah, but you guys have you guys have the system to go down, right, and do analysis, and you can do a spectrum measure and see, right? But of course, do note that the spectrum measure at that point in time will show you this, right? On another day, someone will come into the neighborhood, right, and use some other RF equipment that might interfere again. So, but at least that gives you a sense of what's really happening here.
To answer your question, Jamie, yes, we do. So for the UHF systems, and we have this kind of software that you can free to download. So it called Wireless Workbench, that it meant to do a frequency management and to monitor. So all this software is free to download. Just go to Shure website, you can download for free. And of course, for another type of form factors from 1.9 gigahertz, but of course, for that systems that you need to purchase an antenna. But to answer your questions, we have this kind of management, RF management. So from Wireless Workbench, which is free to download, and of course, you purchase 1.9 gigahertz systems that you can plug the antenna and can use for the scanning.
For a free download, do they need any specific device?
For the UHF one, is you just purely need a laptop.
Okay.
Just download onto your laptop. Then after that, you can really,
So you use your existing wireless to do the scan, or when? How
okay, for our systems, there are certain depend on product lines.
Yeah.
So some of the product lines, you can use the receiver itself.
Yeah, exactly. What are those?
Just now you just mentioned, you just shared the picture, QLXD, ULXD, Axial Digitals. All those are the models that can use the receiver itself. Yeah. For the SLXD, I mean, I'm not sure whether in the past, I think SLX is one of the legendary analog wireless mic systems. So right now, SLXD has latest one, which is digital, SLXD digital wireless mic system, that compatible with Wireless Workbench. So what it does is you can really monitor the frequencies, battery levels. Let's say for SLXD, it has its own rechargeable battery as well. And you can really, for SLXD, you can have an Ethernet port to do a group scan. So which means it saves a lot of times for house of worship personnel. In the past, you just like take your mic, or okay, just want to scan one by one. So right now, you just have a group scan. Just entire receiver, send Ethernet port to all of it, cascade it, then you will deliver the job.
Nice.
Yeah.
Nice.
So it makes it simple and easy for everyone to, it doesn't take an RF engineer to come down or to actually manage the system. It's actually easy. And if you need some graphical examples, Wireless Workbench is the way to go for you to understand what is actually affecting your RF environment. And from there, you can actually shift your frequency. If let's say you're using analogs, for example, right? So it's very easy. So I think one point to also note the difference, I think when you touch on the LED wall, we did see a lot of spikes, and there are still spaces where RF or rather wireless systems can still operate in. So I think one point to also to actually summarize on what Robert has actually mentioned between analog and digital is the channel spacing. So even though the LED wall might be giving off a lot of RF noise, but as long as we have a space of up to 8 megahertz, we can actually squeeze up to maybe 20 channels of wireless, provided you're using a digital reach, right? So then you are not really afraid that, okay, if I have this range of wireless, how do I actually move around or maneuver around LED walls that the church or the house of worship actually spend millions on, for example. Yeah.
Right.
So don't worry. I mean, we all have technology to work against and of course help in all these situations.
Nice.
Yeah.
Great. Okay.
So I think overall, Robert, thank you very much. You covered a lot of things for us. Yeah. So I'd like to hand it back to of course we do have a lot more questions coming in. It's even coming in now. So what we'll do is actually we'll summarize all these questions into a FAQ, which I think Robert will help to answer and send out as well together in a thank you note. Yep. So maybe I'll hand it back to Dina for the closing. Yep. So no, sorry. We'll do the closing ourselves. So thank you very much again. If there are any last-minute questions, please feel free to contact us directly. We are more than happy to answer you. And of course, Robert, thank you once again. Any other closing statements from you?
No, I just hope that you have enjoyed this session, but most importantly, I think a lot of good points have been brought up. So remember those and think about, when you invest in your next system, right? Some of these points will come into play.
Okay, that's great. Thank you.
Okay. Last but not least, before we're going to close up, we're going to share regarding about from Shure side and our distributor. We are currently doing sales design at the early stage. You mentioned about the training program. 2 years back is very important. The first topic we talked regarding about regulations. So right now we have a new campaign. So it's limited time, but for house of worship, we are doing this campaign is up to 1st of September. So what it does is, for example, for any house of worship, mosques, for example, churches, temple, let's say you have existing analog wireless mic systems that you would like to trade in, regardless any brand at all, no discrimination of the brand. We are more than happy to assist you to trade in the latest systems. And there's a lot of cool features regarding about digital wireless mic systems and the software that for our side, in concurrent with our distributor, we can give training as well with a frequency scan. So with that, I appreciate so much, Robert, your insight. We really learned a lot. I hope that members on the floor, they can really take this message and improve themselves, I would say. Yeah, with that, so we wrap up our presentation for tonight.
Thank you once again.
Yeah, sorry again, we can't answer all questions. We still see questions coming through.
Okay.
So thank you very much once again, and we'll get in touch with you in a thank you note. And we hope please send us your feedback. If you wish for more such webinars, please let us know. We're more than happy to organize this once again. So thank you very much. Thank you, Robert. Thank you, everyone. And so have a good evening.
Thank you.
Thank you.